Yeah, I asked yeah, anyone want to get more?
Yeah, Morris.
Fami onde?
Salu. Nada.
Yeah. You want?
No.
You want to try?
This one is you like to try it.
Oh, it's very so if you don't want, you can recommend another.
Oh, Morris.
Beleza.
Yeah. You want to try?
No.
And another one. I think yeah. Georgie. Yeah, use the lower thing and come on, let's try. Today, yeah. Now.
Today is a very bad day. Today is a Saturday.
Not Saturday, this is Saturday.
Today is a Saturday. That's why today feels so awful. That's why.
Actually, it's Thursday today.
Yeah. Saturday we will all rest, do not work, right?
No, like I'm trying to say, since today is Saturday and we're not resting, our minds are really confused.
Really confused.
Yeah, because today is actually Thursday, but it is Saturday.
It's Thursday, yes, Thursday, but it's we have the Thursday class, but it's on Saturday.
Yeah, so today everything.
That makes you confused. Yeah.
Because today is the day we sleep for rest. And then even if we rested the whole week, you know, the weekend still remains the weekend. Yeah, so now if the weekend is taken away from us, it feels like we are not just resting. You know? And continuous work and work and work and work.
I get something. Yeah, because the watching, right? The national day, we have 7 days off. Yeah, actually they only 3 days off. They just together the next week, the weekend together. They couple this thing together, so we have 7 days off. So that means the next weekend we need to back to
You know what to do in our countries and everything. It's a holiday. We never have makeup.
Makeup, yeah.
Like the way China is, like we always have makeup.
Yeah.
In our country, there's no makeup. It's up to the teacher to know how he or she will teach quicker and everything, and like having makeup classes.
Yeah.
Because apparently, you know, if a holiday is given to you, like that's a God-given day. Like
yeah, I know. Because for me, yeah, to be honest, I also don't want to have the class today. Actually, but we are in the Fuzhou College, right? The Fuzhou University, the architecture college. Yeah, the college they have its own rules. If we do not have a class and the other teacher will come here with one class, they will punish. Yeah, me and the teacher, right? They will punish me at first, and then they will ask why the student will not have class today. So for this one, this reason here, we stay here. We have to do something. Can you understand?
I understand.
The makeup, I know. Yeah, it's really make one nervous. For yesterday, I'm nervous that about today what I need to see. Because have this class before, I needed to prepare the material, to collect some videos and prepare what things I needed to talk, what things I need to let you to know and to review. Yeah, I need to prepare a lot of things. Yeah. So college, I also go outside to play. So I maybe not prepare well. Yeah. But it's okay. Yeah, it's okay. Now in Chinese, there's an old saying that 既来之则安之. Yeah, can you get my point? Now we stayed here, and we just prepare have class. Yes, okay, just do these things. Good. 20 times, yeah, want to say something. I just explain that you just listen, right? It's okay. And if you have a question, problem, you just to tell me. Yeah, it's not. It's okay. Yeah, it's okay. So let's continue. For this curve, what we need to know is there's some character point, a character point for A point, B point, C point, and E point, right? A point. These figures will be clear, right? Clear. And I see here this question, this problem, this curve will be tested in the final exam, okay? And you can, yeah, because the previous students, they also test of this question. And, yeah, this semester, of course, we will have these questions about. And in the test, in the exam, I will ask the point of A, point of B, the meaning, yes, the meaning. Yeah. So in this chapter, this part is important. Okay, so now if you don't understand or you can't get point, doesn't matter. Yeah, doesn't matter. After the class, yeah, to just take it out, take PPT out, and to read carefully. Okay. So from this figures, we know during the 0 to A, this period, the concrete just in elastic, right? Elastic deformation, and if we remove the load, it can return it back, right? There, we name this period is elastic. And for A to B, that means the plastic deformation is caused. Yeah. Also, the stress grows with the strain increase, right? It grows with the increase. But the relation is a non-linear, not like 0 to A point. They are the linear relationship, but A to B is a non-linear. Yeah. And for C point is the peak stress, right? Peak stress. What we observe from the machine, there's a peak. The peak value we write it down, and as just a critical value. And to E means there's a descending branch, and the sample, the specimen, it broke. So from this figure, we need to know the point, meaning, and the character, behavior of the concrete under this specimen, this curve we obtained that based on the specimen under the one direction load, right? One direction. And later, this semester, we may talk the specimen under two direction load. What behavior of this sample's stress strain curve, and also the chill direction load applied to the concrete. What behavior it should look like in this class? What we need to know to learn, right? And based on this curve, right? The last class we talked about some model. Some models they proposed by researcher, right? And for Chinese code, there is a model look like this. What the character of this model is? There is the constant, right? When the concrete under the load, the stress strain curve will grow at first, but to here they will constant, do not have the descending branch, right? This is the model used in China code, and there is some formula. Good formula here. Just if you maybe after the undergraduate you go some other place to further to do some research, you may use, you may learn and do something. And for this model, this proposed by these guys, they from America. Yeah, America used it. For these models, they had the descending brain, but for these models, they have a peak. During the peak, peak values, they may difficult to simulation because they do not smooth in the curve. They have a change, change in the modulars. So this is the disadvantage of this model. And another Japanese and Tsinghua researcher, right? Tsinghua researcher. This is a Tsinghua, and also the Chinese, Japanese. Yeah. They also based his experiment. They proposed some models. Yeah, for us, we just know that it's okay. The internal, the knowledge that we need to master is the stress strain curve of the concrete. Yeah, this curve. Yeah, this curve and the different point meaning. The model proposed here just help us to get the specify the value, how these values, right, these models, they give us to calculate the point. Yeah, I remember the last class that we talked to here. There is three modulars. Yeah, these three modulars we need to know during the stress strain curve. For the original point, these modulars, and they had a relation with the angle, right? Angle, the tangent, EC equal to tangent alpha. Yeah, alpha. They named it as elastic modulars. These three modulars, okay. And for point, we line the point on the curve to the original point. Yeah, this one is the secant modulars. Sometimes we will compare this modulars, secant modulars, with the elastic modulars. Yes, we compared, and we know the elastic modulus is larger than secant modulus on the curve, right? Yeah. Or we go back to see the concrete. This one point is the elastic modulus, but this one we line it together. This also had a relation with the angle, right? Of course, definitely, the secant modulus will smaller than the elastic modulus. Okay, there the relationship I hope the student can master it. And the tangent modulus will be different. Tangent modulus means the point we choose. Yeah, we choose on the curve and do a line to tangent it. So in this situation, the tangent modulus may larger, right? May larger than the elastic modulus. They have this relationship. You student need to distinguish it. For this relationship, we can definitely to see, but the tangent modulus sometimes may larger, sometimes may smaller. They need we to observe from the curve and to get, okay? And now these three modulus, and we can easily to explain that before I just see this curve we obtain from a specimen on the one direction load, right? And we just increase the load, give it the load F. Do not remove the load until the specimen broke. But for here, this curve, that means we apply the load, come to here, this point, and remove the load, right? Of course, in this part, I have mentioned they exceed a point. That means the plastic deformation already exists in the specimen. So when at this time, we remove the load. Of course, for the elastic deformation, they will recover, right? But plastic deformation will exist in the specimen. So for the curve, they will do not go back to the original point. They have a distance, right? For this phenomena I just described here, but actually this phenomenon have been already observed from by the researchers. They just observe this phenomenon and then to go back use the stress strain curve to explain. Yeah, and for we to learn the property of the concrete, the mechanical concrete, we needed to know some different condition, the concrete stress strain curve behavior. And then it may help us to do the further structure design, right? So several times, right? When it comes back to here, because here is a elastic deformation. Plastic deformation. That means they cannot recover. So again, we apply the load. Yeah, the stress strain curve, they grows, right? And come to these values. Again, we remove the load. They come back, and then the plastic deformation we can obtain. From the code, they use the formula to get. And for this stress strain curve, where we will how to use it, stress strain curve, that's in earthquake analysis, or in the wind load, the load varies with the time. This stress strain curve may be used. Yeah, I can give you some examples. Yeah, for the building, right? This is the building, and the earthquake comes. Of course, the buildings will vibrate, right? Evaporate. That means the earthquake load applied to the buildings. Yeah, building just consists of the concrete, the beam, the column, another, right? Yeah. That means the concrete on these buildings, the load applied to him, they grows and come back, grows and come back. So this cycling load process just simulate, they simulate the earthquake applied to the building or the wind load, right? Wind load comes applied to the building, or the building will vibrate. So in this case, or in this situation, so this stress strain curve will be used. Yeah, this one also the cycling load. What the difference between here is, look at here. This is also stress strain curve. What I mentioned before from these figures, right? The load always comes to the period A between the range of A between B, right? A between B. You know here, just here. So the curve will look like this. But for there, that means we apply the load comes to here, and then we remove the load, it will come back, and then apply. So at a different range, different period that we remove the load, the stress strain curve will be different. Okay? Yeah. The behavior under repeated axial compressed cycling load from these figures that we know. Yeah, and look at here, the envelope, what we get from this point. The envelope, the shape is identical to the curve that obtained from this one, right? Yeah, they will have this relation between, this is the cycling load, and if we just get this peak point and draw the peak point line, the shape is identical to the specimen under one direction load. This is just okay. Right.
So which one is the monotonic?
Monotonic load is this one. Monotonic load is just this curve. I mentioned just a specimen under one direction. 单调的, right? That's just one. We apply the load is always until the specimen destroyed. We remove the load. Yeah, just one time we apply the load. And for this one is the cycling. That means we apply the load and remove, and then apply, remove. They repeat it. Yeah. The monotonic load just a curve. Look at here. This one is the monotonic load because we apply the load. And we apply this load until the specimen destroyed, we remove. But for here, for here, it is the cycling load, right? Cycling load. We apply and remove, apply and remove. Okay. And for the curve, for this curve, some people propose the model formula to describe. They establish the relationship of the envelope. Yeah, and this is the intersection, the point of intersection, right? Look at here. They drew this line. They drew this line and established the relationship of this one with this one. Yeah, this secondary model proposed for seismic analysis. Yeah, seismic. So if we, for structure design, they related so many aspects for like the seismic analysis or wind load analysis. They have a different branch. Yeah, and what I introduced here just open a window for you. If you may interested about different branch, right? Yeah, and further you can focus on this area and further to do some research. And for here, I just introduce from this phenomenon, the researcher they also built the relationship and build this model in the seismic flow. And for they draw this curve, right? They can calculate this area. Yeah, I can see at first here. Yeah. They can calculate this area. This area means if this area is larger, that means this building is good at resist seismic load. Yeah. So they have this relationship and they have this meaning. And in academic name, the lag curve, 智回曲线, like in Chinese, 智回曲线. Yeah.
It's called what?
智回. Lag load, lag curve, right? I'm not sure, but in Chinese, it's 智回. 智回曲线. To describe. Yeah. Okay. Yeah, take rest.